multiple words for one word in another language, such as multiple words for love. We pretty much have like love. Okay, so it's hard to translate. So what I'm saying is we can apply that to cultural things as well. It's hard to translate everything of a culture into another culture, right? Each culture usually has their own sets of beliefs and traditions and values and norms and things like that. And it's hard sometimes to compare that to another culture. Okay? So, like here. Okay? The advantage of doing some culturally sensitive research is examining the effect of culture on some variable of interest. In this way, they help make psychology more applicable around the world. Okay, so that's nice. Disadvantages, though, is some situations and some specific words do not convey the same meaning when translated across cultures. Like I said, cultural differences can leave room for alternate explanations. Okay, and for example, misunderstandings can occur during the research process. So it's kind of hard to isolate all the variables there too. We're working with, problems such as maybe a third variable problem in these kind of researches. Okay. All right, so my slides got all kinds of messed up here, guys. Okay, so observing is an intrusive strategy. We like observational techniques, systematic assessment, including overt behavior. When I say overt behavior, what we're meaning is behavior that we see. Okay, so this raises questions for us. Okay, how should we observe people? There's quite a few different ways that we can observe. Do we bring them into a laboratory or a manipulated environment? Or do we observe them in their own natural environment? Do you guys remember the two different types of observation? We talked about it.
I forget. I don't remember what they're called. Is that what you're asking, the name of it?
Tell me which ones they are.
Where you just sit there and, like, where you're talking about, you sit in the lunchroom and you watch them, or you actually get involved with them.
Okay, so the first one, if we're just watching them in their natural environment, it is? Naturalistic, yes, naturalistic observation. And then if we become, if we participate in the environment, it is? Participant observation, okay? Very simple. But how do we do it that way? Or which one are we going to use for our observation? Okay? That's another question we have to consider with this. How should we collect the data? What are we going to measure? What are we going to quantify? Okay, what are we going to be looking out for? Should the observer be visible? Should people know that you are being, or that they're being watched by you? Or do you want them to not know that you're observing them? Maybe they know that you're observing them, but they can't see you. That could produce some different results, right? Or what if they know you're observing them and you're right there in their face and they know you're there, right there? That could produce some different results, right? So we have to ask all these questions. Which way would be best? Okay? We have to think of reactivity, which simply means the presence of the observer alters the behavior of those being observed. And from this, we've seen the Hawthorne Effect. Okay? This was a really cool study. I like the study. They did this, what are the years? 1924 to 1933. And they actually went into a plant called the Hawthorne plant in Illinois. And what these researchers did is they were studying the variable of how long it took workers to complete a task. And they manipulated the environment. Okay? They actually manipulated it in different ways, one at a time. They would maybe change the settings of the lights, dim them, or make them really bright. They may change the length of time for their breaks, shorten them or lengthen them. They changed work schedules. Okay, what time they came in, what time they left, the hours they worked. Okay, they changed all these different things in the environment. And they wanted to see if any of them had an effect on the productivity levels. Okay? Now, the catch here is all the workers knew they were being observed. Okay? So when they manipulated the environment, so they changed the lights or whatever, whenever they started the manipulation, the workers worked harder and productivity increased. Okay? Because they knew they were being observed. They knew they were being measured. And we call that the Hawthorne Effect. the effects on our behavior when we know we're being observed. Okay? Alright, and those are pictures of the factory and the actual thing here. Let's see here. I just said all that, so we'll move forward. Okay, so let's talk about case studies. This is another way of data collection. Okay, so first is observation. Now we have case studies. Case studies are usually of a very, very small unit, an individual, family, or maybe a small group. Okay, they are very specific to just that one unit. It's intensive. It's an intensive examination of that one unit. Okay, so we do a lot of case studies on mental illnesses. Okay, if you go on to grad school, which I hope a bunch of you do, especially in social science majors such as social work, psychology, sociology, counseling, any of those, you won't be able to count how many case studies you do. I think I was doing case studies in my sleep. Okay, but they're fun. And like I said, they're just an intense examination of that one case. What a disadvantage of that would be that we can't generalize it though, okay, because it's so specific. And here's an example. This is a case study on Cho, who was the Virginia Tech shooter. Okay, they found in their case study that he was really violent. Okay, and felt very lonely and depressed. A lot of people were actually worried about him, professors and things like that, because he would have these violent writings. He wrote a play that was extremely violent. Okay, however, even though they were concerned, there was nothing about him that would call for isolation or hospitalization or anything like that. Okay, so there's really nothing that they could have done more than what they were doing. And what happened was he went on a massive killing spree and killed 32 people. Okay? Now, this is a very specific case study because everybody who is depressed or lonely or violent, are they all going to go and shoot out of college? No. Okay, this is actually very rare. It's really rare. Okay? And we can't generalize this specific, unusual case to everybody. Okay? So just remember that case studies are very hard to generalize. Alright, so let's move on. Asking takes a more active approach. So we're talking here about questionnaires, surveys, and interviews. Here's another one of data collection. Okay? We ask people about themselves. It's a more interactive way than just observing. Okay? When we observe people, we just observe what's going on. We're not asking them about their experiences. We're not asking them about their emotions or thoughts or opinions or anything like that. We're just simply observing. Okay? With this type of data collection, we are asking those things, which is great. We use self-report methods, which is questionnaires or surveys. Okay? These are cost-effective, so they're nice. We can get a lot of information from a large group of people rather quickly. That's wonderful too. We also use interviews, okay? And interviews can happen one-on-one or they can happen in a group setting. We have certain skills that we use for interviews, such as our listening skills, obviously, right? But we also have certain skills that we use in asking questions, such as closed-ended and open-ended questions, okay? Closed-ended questions are simply questions that you can answer with one word, okay? Or like a rating scale, okay? I want you to rate your experience in this class on a scale of 1 to 10, you give me a one-word answer, right? You say a 3, or hopefully it's like an 8 or 9. But that's a one-word question, or one-word answer, so that's a closed-ended question, okay? Yes or no questions are closed-ended. Those are good when we want to measure things, okay? We want to apply numbers to them, those are great. Because I can count how many times you guys respond to a yes question, or respond with a yes, or respond with a no, or rate things, or whatever. Open-ended questions, we're looking for more of those personal experiences. We're looking for you guys, or you're wanting in the interview to open a conversation, okay? How do you feel about this class? Well, I feel good, this, or I hate it, this, this. Those are open-ended questions. okay? We want to know your experiences. We want to know how you feel about it, your emotions, thoughts, all that. We also use experience sampling. So if you're doing a research project, okay, it might take some time, you might interview people, the same group, a couple of times, right? And we call that experience sampling. And that way you can, rate their experiences and things like that over a course of a couple of times of asking questions. All right. So there is different methods. Let's keep going. Self-report bias. Here's some more bias here, right? All right, so we have action-based methods that have a form of bias with it. Have you guys ever gotten a questionnaire, maybe exaggerate a little bit? Yeah, we all do it, right? Okay, I don't know, some examples that maybe they ask you your GPA and like, I'm gonna say I got a 3.9. You know, things like that. We exaggerate a little bit. So in these self-reporting methods, such as surveys, questionnaires, and interviews, sometimes it's hard to know if the answer is truly honest. Okay? Because it's human nature for us to put ourselves in a good light. Okay, we want to impress people, especially people that we view that as authority. Or when we are involved in a research project, we usually view the researchers as having some authority, right? So we want to, make ourselves look good. So we have a desire to respond in a socially acceptable way. Okay? We also have a desire to take good. Alright? And then it's just that we respond in ways that we think other people want us to respond in. Okay? We also have the better than average effect, where we tend to describe ourselves in more positive ways that may be a little bit exaggerated. Okay, I'm not saying it's completely untrue, but maybe just a little bit more exaggerated. Okay? Alright, so let's go ahead and move forward. And let's talk about response performance measures. Okay, does anybody remember William Moot? Anybody? He created the first what? I heard someone say something. We're talking about the first week. Yes, thank you. He created the first laboratory, okay? So that's wonderful. Psychological laboratory, we'll say that, okay? And him and his students were studying response performance, okay? And so they helped develop these three major types of response performance. Response performance is researchers who quantify perceptual or cognitive processes in response to specific stimulus, okay? So basically what that means is we're measuring how your brain responds to a stimulus. That's it, okay? And here's the three ways that we do that. We have reaction time, okay? This is the most useful tool when we are using cognitive psychology, okay? And what we're talking about reaction time is maybe you're staring at a computer screen and we tell you that we're going to put up an object or a shape, and you just need to identify and tell us. Okay? So we put it up, and you say it's a computer. And the reaction time there, we are measuring how long it took your brain to process that shape and to identify it to tell us. Okay? Pretty easy, right? So that's reaction time. Response accuracy. Okay? We are seeing how accurately you can get the stimulus. Okay? So we might throw a twist in there though, to make it a little bit harder, such as you're staring at the computer screen and we ask you to, just focus on the right side. We don't want you to look anywhere else, we just want you to focus on the right side. And if you see an object here, we want you to tell us what it is. Okay? And here's the thing is, would you get the question right more often if it was on the right side where you were staring, or if it was on the left side where you weren't paying any attention? And that's how we measure accuracy, okay? We do different things like that, okay? And then we have stimulus judgment, okay? For example, we may throw up two objects on the screen, and we may ask you to tell us the similarity. That's going to take you a minute, right? You have to judge the similarities between the two objects, okay? We might ask you just to identify the different attributes of the object, such as, it's a blue square. or something descriptive like that, okay? So you have to make judgments. All right? And that's how we measure performances there. So here's a fun little diagram. We're showing you that this is response accuracy. Just paying attention, you have to decide if it's the same or different, and he's clicking one or the other. And we're seeing how accurate his responses are. We're measuring him, okay? And so that's really a good setup for those response performance methods. All right, one thing about those though, it can be costly. All right, and we don't like costly research, we kind of like the cost-effective ways. All right, so let's talk about the brain and body activity that we can measure directly in real time, okay? We have psychophysiological assessments, okay? And that's how we examine our bodily functions, our physiology. Changes in association with behaviors and mental states, or psychology, okay? So think of a polygraph. Everybody knows what a polygraph is, right? We use them to see if people are lying. How do we do that, though? I'm sorry?
They measure heart rate, blood pressure, respiratory.
Yeah, and respiration levels and all kinds of things like that, right? And that's our physiology. Those are symptoms that our body produces when they have found out when we are lying, right? Supposedly. Okay, when we experience stress, our bodies react in certain ways like this. Okay, we have these symptoms. Okay, and that's what the polygraph is measuring. It's measuring the physiology symptoms, but we know that those symptoms are related to certain mental activities. Okay, so we're able to measure that. All right, so here's some of the ways that we do this. Okay, we have the polygraph. We're going to get into these other ways. Okay, the EEGs, the PET scans, the MRIs, the fMRIs, and CMS. We're going to talk about all of these. So let's talk about electrophysiology. This measures electrical activity in the brain. And we use an EEG to do this. Okay, it produces, I cannot say this word, electroencephalograms. Any med students, pre-med? Anybody good with pronouncing these big long words? What is it? Thank you. Every time it comes up, you have to say it. Okay? Alright. It reflects all brain activity. Have you guys seen the brain scans where you see all the different colors, the blues, the greens, the red, orange, the yellows, all that? They look really busy, don't they? Right? You might have some big spots over here, some small spots over here, different things, but it's really hard to differentiate the different regions of the brain in these scans, and which one might be firing more, or which one is responsible for that behavior. We call them being noisy, they're imprecise, we can't isolate them as to what's happening from the stimuli. Okay? So what we've done is we've created a process to help us do that. And we use event-related potential. And so what we do is we use many trials, okay? We will subject the participant to a certain stimulus, do the brain scan, see how it lights up. We'll change the stimulus, do it again, see how it lights up. We'll do it again with another stimulus, see how it lights up. And this allows us to isolate the different regions in the brain and see which one's firing when, okay? So it's really nice. We like that. But it can be time-consuming and expensive. All right, so let's go on to brain imaging. We have PET, which is positron emission tomography. It provides computer-aided reconstruction of the brain's metabolic activity by tracking a radioactive substance. So yes, we put radioactive in you, so that way we can see it. We use MRIs, okay, to really look at this. It's a powerful magnetic field that the tissues in the brain respond to. This is very powerful in providing us info about the structure of the brain, okay? And then we move on to fMRIs, the functional magnetic resonance imaging, and this measures blood flow, okay? The oxygen levels in your blood flow throughout your brain, so that way we don't have to put radioactive substances in you. We just simply look at the oxygen levels and the differences, okay? All right, let's move forward. I will have this up for you guys tonight, okay? So don't worry about your part. There's a lot of information. Let's take a TMS. It's a very fast, powerful magnetic field which disrupts brain functions in certain regions. Okay? So what we use is a coil, we place it against your scalp where we know the regions of the brain are, and I could disrupt your speech. Okay, make you unable to talk. I can disrupt your coordination. Okay, your mobility. We could do things like that with TMS. And what this does is it allows us to isolate a region of the brain to kind of let us know what region is responsible for what behaviors or for what things that we're able to do, such as speech. Okay? It's a powerful method for examining which brain regions are necessary for specific psychological functions. Now remember, I did say that there's a lot of different regions that work together and it's very complex in order to make behaviors, right? Okay, so we still understand that. There's still a lot of different regions that are working together to help us talk, okay, to produce our language and our speech and things like that. But we are able to identify a region that will, take away your ability to talk, okay? You may be able to think of what you want to say. You still understand the language and everything else, but maybe you just can't move your mouth in order to do it. Okay, have you guys ever seen that happen before, like on a TV show or anything like that? Yeah, we've seen it before in media, okay? And that's what I'm talking about, okay? Let's see here. This can only be used for short durations of time to examine brain areas because we place the coil on the scalp, okay? So we have to be very careful with that. Alright, let's keep moving. So let's talk about animals, right? Because it's not ethical to do all of our research that we want to do on humans. Okay, such as we're getting very interested in genomes, how our genes affect the way that we behave and how we act. It affects our, psychological disorders, our physiological illnesses, things like that. Okay, so we're getting very interested in it. But we can't go to ask people to participate and we alter their genes, right? Probably not ethical. I'm going to tell you that's not ethical. So what happens is we have to use non-human animals, okay, such as mice, to observe these behaviors and things like that, okay, with these unethical studies that would be, unethical to do on humans. Let's see here. Forces that control the behaviors of all animals exert their effects in similar ways, okay? A lot of us animals, we all have some of the same survival instincts and things like that. So we can confidently measure some behaviors of mice or other animals that we're using to apply to human behavior as well. Okay, let's see here. We use transgenic mice. They're produced by manipulating the genes and developing mouse embryos. And that again helps us study, cures for diseases and things like that. Okay? Alright, so here's some of those cute little mice. We love them. Okay, so now let's talk about the ethical issues, okay, with our research. And there's a few of them that we really have to consider every single time we create a research project. When we select a research method, we must know what ethical issues are involved. Okay, is there physical harm? Is there emotional harm? Do I need to let my participants know every little bit about the research, or can I deceive them a little bit? We have to know these ethical standards in order to conduct our research appropriately. We have to adhere strictly to the relevant ethical guidelines maintained by all colleges, universities, and research institutes. And remember I talked about the IRB on Wednesday? Here we go again. The institutional review boards. They review all proposed research to ensure that it meets scientific and ethical standards. We have one, Ohio State has one, Ohio University, Marshall, every university that conducts research has an IRB. I ran into our IRB one time. Do they still do the celebration of scholarship here? They do. Okay, great. I participated in that quite a few years ago. And my goal, I was going to work with a professor to research the symbolism of prison and being tattoos. And the reason why we wanted to do this is we felt that we were able to study the symbolism and create like a handbook or a guide or trainings that would teach the staff. We could change some policies, make it safer for both inmates and staff members and things like that. So I created this huge research project, we had everything down, I knew the budget, hotels, everything, it was great. I got approved by the IRB. Why did I have to do the IRB? Yes, I was working with humans, but I was just getting some pictures of them and interview them. Keep that question in mind as we go through the ethical standards, okay? I did get approved from the IRB, but there was $1 million insurance policy when we go to the prisons and got a student here, and no one wanted to pay it. So I didn't get to go. But let's think of the ethical issues with that research. Remember, I was going into prisons, okay? Inmates are a protected population, all right? So remember that. Remember, I was just going to take pictures of their tattoos and interview them about why they got them, the symbolism behind them, things like that. Okay? Remember that as why when we talk about this ethical standards. So one thing we have to keep is privacy. Okay? If you guys decide that you're going to participate in a research project, you probably don't want me telling everybody in the next class, hey, Joanne is in my research. That kind of I wouldn't want people to say, we're looking at this. So we try and keep privacy it's very utmost concern. Also, you want your information kept private, don't you? Because in a research project, I'm probably going to find out things about you that you may not let everybody know. Okay? Here's another thing. Is it okay to observe people about their knowledge? That's an ethical question. Remember, we may want to observe people without them knowing because we know that they change their behaviors when they know we're observing, right? But is it ethical to do that? What if I decide that I'm going to use this class, and I'm going to observe you guys outside of the classroom to see how your behaviors change from outside to in here? And I didn't tell you. How would you feel? Would some of you feel a little violated? Some of you guys probably wouldn't care. Some of you guys would be fine with it, right? But we have a mixed opinions about it. Okay? And that's why it's an ethical consideration. Okay? We'll talk about the risks and benefits of these things and how the IRB rates those. Okay? But on to our ask for information, some topics not be raised because they may be too personal or otherwise inappropriate. For example, what if I'm doing a research project and I'm doing interviews and I start asking about traumatic sexual experiences? Is that something that I really need to know for my research? Should I raise that topic? Could it be emotionally harmful? It definitely could be. So that's an ethical consideration that I have to think about when I do my research. Researchers must consider how observation and questioning may affect the individual they are studying. Okay? If you see me following you around campus and I'm observing you, would you kind of get a little anxious? Maybe a little bit, right? What the heck is the professor doing talking to me? You might get a little anxious. I might change your behaviors. I might make you a little stressed out. You gotta think about these things, okay? Alright. Let's go on to access to data. Who can get access to the data that we gather? Because guess what, guys? Some of your personal information may be involved in that data. We have to make sure that the data that we either publish or that we let others read do not identify our participants personally. Okay? That until we have set all confidentiality and have set all our privacy on a need-to-know basis, okay, we have to consider who access to the data, okay? And just an FYI, we don't point it out in this chapter, but if you are a participant in a research project, after it's finished, you have every single right to ask for the results. Okay, even if they don't publish them, you can go to the researcher and say, I would like this result. It makes sense. Okay, participant confidentiality should always be guarded. Okay, you do not want me releasing information that I found out about within my research. Okay, you do not want me to release that Jane Doe, who is 25, started smoking marijuana when she was 12 because of these, home things that were going on, and this led to more criminal activity and things like that. You don't want to identify anyone like that to you. We like to keep our information confidential, and that's part of us, what we have to do in our research as well, okay? We don't want you to be worried about the information we're going to publish. We want to make sure that you are safe, safeguarded, and your information is very well protected. Let's see here. We have to guard it so that your personal information is not linked publicly to study's findings. Okay, that we don't want people to be able to identify you by reading our, published article about our research. Let's see here. We also want to make sure that you feel safe in our research with your information, okay? Because if you don't feel safe in our research with your information, are you going to give me a lot of information? Probably not, right? Because if you know that so-and-so is going to find out that you did this and this, you're not going to tell me about it. Okay, so the more safe that you feel with your information being confidential, the more likely you are to give me more information that I need for my data to be more accurate. Okay? Alright, so let's move forward. Informed consent. This is a big one, guys. People who volunteer for psychological research have the absolute right to know what will happen to them during the entire study. Okay? So let's say that you want to participate, there's a research project going on here and you're going to participate in it, and they're going to observe you eating an apple. And that's the only information you got. Well, if they want informed consent, then you ask them exactly what's going on, okay, what are you looking for, what are you observing, what are you measuring. They have to tell you in order for you to give informed consent. Okay? Informed consent means you know every aspect of the research study. Okay? And that is an ethical standard. We require informed consent. Now, you can deceive if you need to. Because remember, we talked about if people know that they're being observed, they're going to change their behaviors to skew the results. The IRB has to approve for you to deceive your participants. Okay? Because we have to measure the level of risk there. But if you do deceive them during the, introduction to the study, after the study is completed, you have to let them know exactly what was going on and let them know that you did deceive them. Okay? Alright. So now we have relative risks of participation. We've talked about some of these risks. Okay, confidentiality, are there going to be harmful effects, different things like that. So the IRBs, they look at these potential risks, and they look at the benefits, and they have to weigh them. Okay? If you're going to deceive your participants in your research study, why are you doing that? Is it necessary? Is it going to be beneficial? Okay? And if they feel that it is, then they may go ahead and approve your research. But remember, if you're going to deceive in your research project, and Shawnee State's IRB may approve it, but then, I don't know, they try and replicate the study at Ohio State, their IRB may not approve it. Okay? So just kind of remember that. Alrighty, let's move forward, because I got about, a little over 2 minutes. Okay, so let's talk about how we analyze our data. Alright, let's just move forward. So let's talk about good research, valid, reliable, and accurate data. In order to have good research, we need these 3 characteristics. Okay? Internal validity just means, is it valid? Okay? Are you measuring what you want to measure? That's what that is. Okay? Now, remember my example of where you sit in the class? Grades. Different grades. So let's move to that real quick. And let's say that I am studying that. Okay, so my variables of where you sit in your grades. In order for my study to be valid, I have to make sure that you guys are all paying attention. okay? Because if the back row is all on Facebook, the middle row is sleeping, and the front row is paying attention and writing notes, if someone walks up and down the aisle, it'll actually turn back on. But then my question's not going to be valid because we're not able to measure exactly how everybody's paying attention and where your seats are. You get what I'm saying there? There's these other variables that are playing into it, and I'm not able to measure what I'm trying to measure. Okay, so we have to make sure it's valid. Are we measuring what we want to measure? Reliability. Is my information, my data reliable? If I keep testing it and testing it and testing it, am I going to get similar or the same results? Because if I get varying results, if it's different every single time, then it's not reliable, right? So that's all that means. Okay? And then accuracy. Is our data free from error? And I'll tell you what, almost no data is free from error. Because we have two different types of error. We have random error, which is amount of error introduced into each measurement differs each time. We'll talk about that here in just a minute. And systematic error, which is the amount of error introduced in each measure is constant. Makes no sense, right? Let's say you are timing a behavior, okay? And you're using a stopwatch. What are some problems with using a stopwatch when you're timing somebody, doing something? Maybe you're timing, think of a race.
Reaction time, you hit the button.
Your reaction time is going to differ, right? You might be a second late, you might be a second early, you might be 2 seconds late, you might be right on time one time, okay? The systematic, so you've got different varying measurements there, okay? And you know they're not exactly accurate because of human error. Systematic errors would be, we're using the stopwatch to get the race, and let's say, the person who got it completely, concrete, or the person finishes in about the same time every single time, okay? We're just going to pretend that it's a perfect world we can make that happen. And then you are a second late every single time. So you have a constant error, okay? It's always the same number, but it's a second late. Usually we are unaware of this. Here's the diagram of it. So here's our stopwatch, and here we've got different seconds. We can average it out to 236, okay? And here's our actual time, which most times we don't know our actual time, okay? And there's a systematic error, where it's the exact same every single time, but we know that there's probably going to be a little bit of error, okay? I know it's really confusing, but you'll get it. All right, we're going to go ahead and move forward. And we'll talk about errors. Maybe this will help you a little bit. Descriptive statistics. Descriptive statistics simply describe your data. Okay, that's it. What we do first is we use raw values. When we think of raw, we think of untouched, right? Like raw meat, you don't cook it. Raw vegetables are not cooked or steamed. They're untouched. So that's what we're talking about with raw values. We haven't touched them. Okay? We are just simply putting them down, we haven't, averaged them, we haven't, done anything to them, organized them or anything, just simply our raw values. So then what we use, and we try to find errors in our raw values. Okay? That's our first step. So for example, like if we have asked participants to be in our study, I'm going to look through my data and make sure that I don't have a 113-year-old participant. That's probably not correct, right? Okay, and that would be an error. I'm also, if I'm doing one on alcohol, okay, if I find an alcohol blood content of 50%, that's probably an error, okay? Probably not going to happen. So those are things I'm looking for, okay, are these errors. Alright, so then we summarize our data by using descriptive statistics. We use this with central tendency. You guys know exactly what I'm talking about. With your mean, median, mode, right? Okay, so your mean is the average, your median is the middle number between the highest and the lowest. Okay, your mode is the most frequently occurring number in your data. Alright, so those are descriptive statistics. We use them all the time. You guys read them all the time. Then we have variability, okay? And this describes how widely dispersed the values are about the mean. Standard deviation, right? Everybody have statistics? Yeah, most of us? Okay, good. So you guys know what standard deviation is. We use this to really help us look at the range of numbers. Oh shoot, I'm so glad you reminded me. I do now. Okay, so we use the standard deviation to help us find the range and really look at how dispersed our numbers are. Think of a bell curve when we're talking about grading, okay? All right, so I'm going to move past that real quick. Let's talk about correlations and with variables. So with descriptive statistics, you can also use them to summarize how two variables relate to each other, okay? We use scatter plots to really visualize it, okay? Well, that's to visualize relationships. You know, how, I'll get into how they show it. Okay, so we like to have a correlational coefficient. Anybody know what I'm talking about? Think about standard deviation, okay? When we talk about statistics in psychology and these kind of research methods, we want to have values, natural values that fall in between -1 and +1, okay? They will always fall into that when we're looking at the correlational coefficient. We're using our scatter plots, okay? I will let you know that there are computer programs that will do this for you now. Okay, but we have a negative and a positive relationship, and this is what it shows. When I say a negative and positive relationship between the variables, I'm not talking about good and bad, okay? A negative relationship does not mean that there wasn't a relationship. It means that there very much is a relationship, just like a positive one. A positive correlation means that both variables increase or decrease together at the same time, okay? They move together, whether it's up or down. All right, and a negative correlation means that when one variable increases, the other decreases. Let's practice. All right, so this is a scatter plot of our balance, okay, with the level of intoxication. So when we have a very low level of intoxication, we have a very high level of balance. We're pretty good at it. As our intoxication level increases, our balance decreases. Can anybody tell me what correlational relationship is this? It's a negative one, okay? Because as our balance decreases, our level of intoxication increases, okay? So here are some different correlation relationships here. Here's a negative correlation, perfect, okay? Perfect run, all right? Here's medium, it's kind of scatter a little bit, but it's not a line. There's none, it's just whatever. And then we see the positive correlation and the perfect positive correlation, okay? Alright, so let's, and you see the numbers, how they are measuring us between -1 and +1? Alright, you guys will get more into this the further you go into psychology or research methods or anything like that. Alright, so let's get this finished. Let's talk about inferential statistics, okay? This helps us generalize our findings. They are used to determine whether differences actually exist in the populations from which we draw our samples, okay? So let's talk about the alcohol kind of study we've been talking about, where we have sober drivers and we have drunk drivers. Are we able to see a significant difference in the levels of performance between sober drivers and drunk drivers? Yes, we can, right? Otherwise, it would probably be legal for you to drive drunk, right? We know that there's a big difference between them. So it's we can say that's statistically significant, right? We can see that there would be a relationship between your performance level in drunk driving and your performance level and sober driving, and we see a big difference between the two, right? We can measure it, okay? And we see that there's a statistically significant difference there. Alright? We might be able to replicate the study. Instead of using drunk driving, we use stressed out drivers. Okay, we could probably infer that there might not be as big of a significant difference there, right? Maybe. Okay, we'll move on. Alright, well let's talk about meta-analysis real quick. Meta-analysis is simply a type of study. What we do is we take a lot of other research that's already been done, we review their analysis, their data, their findings, okay? We highlight all of it once, and that's a meta-analysis. A lot of researchers really like meta-analysis because they feel that it is stronger evidence for that research. Because what we can do in here is I can have you guys each do your own research on one single topic, and then I can compile it all together, because guess what? Even though you guys will probably find a bunch of the same information, there's going to be a bunch of you can find more information outside of that core information that we can actually get more than just what maybe I can do by myself. Okay, does that make sense? Right, we like meta-analysis. But it's also saying that, you know, the study's been done more than once. So if I do it for myself, it's only been 1 month, 3 months, right? So we have multiple people doing it. Okay, so that allows us to say it's very, we have a lot of evidence from that too. Okie dokie. Do I have any questions? No? Alright, well, you guys have a good weekend, and I will see you on Monday. We'll start talking to you.